let's compare the high-low method and regression method in calculating the cost function. We have those examples with the data input section. The Mr. Liao, CEO of a manufacturer of fine china and stoneware, is troubled by the fluctuations in productivity and wants to compute how manufacturing total costs are related to the various sizes of batches of output. Maybe these guys want to know if they apply some specific batches, number of batches, how to be the the cost, the total cost would be. So the requirement is predict the total cost for 25 batches with cost functions by high-low analysis and regression analysis. Let's just start from the high-low analysis. As we discussed in class, high-low method, we use just two dots in a graph, the highest one and lowest one. So first, let's take a look at this, the data input section. We found the lower one and the highest one, right? So let's put the highest one of the total cost of Y, 320 total cost, and the batch size is 30. And the low here, 110 and 9. Okay, so the reason why we collected this high and low in terms of total cost and the batch size is to get the changes between high and low. That is the y-axis. In the y-axis, the rise part. At the end of the day, we'll get the slope, the alpha from this information, and then the changes on the batch sizes. So 210 is rise and 21 is run. So we got these elements of the slope information, which is cost driver. So 210 divided by 21, and then 10 is the slope, which is variable cost per batch. And then fixed cost per month. How do you get this? It's correct. We use the total cost is equal to the variable cost plus the fixed cost. Then the fixed cost is equal to the total cost minus variable cost. Is that correct? So we can apply any of this, any of high or low information. So 320 is the total cost minus variable cost is the fixed cost. So what is the variable cost? $10 is the cost driver, right? What is the variable cost per batches? Here you go, times 30. So the 20 is the fixed cost. Again, the total cost minus the variable cost. Okay, so we got it. Then we got the cost function y is equal to 10 times the batches, number of batches, plus fixed cost 20, right? And then the CEO expected the total cost is 25 batches. So 25 here. Now let's apply this 25 into the cost function to get the predicted total cost for about the lot size. The 10 times 25 plus the fixed cost. Then the predicted total cost is 270. Okay? So we use this only high and low information using the high-low method. But if we use only this two information, the rest of them are useless. No. Now, when we use the regression analysis, then we can satisfy all these the examples. Okay, let's do the regression analysis by graph. We'll draw just one line, linear line, on all the dots that are satisfied with this linear line with high confidence level. So let me drag this X and Y information and insert, and do you see here we have scatter chart, and choose the scatter chart. So total cost in y-axis and x-axis shows these batch sizes. So all dots are this information. Okay, so in order to satisfy all these dots in a one linear line, we choose just one of them, any of this. Okay, we choose one dot and add trend line, and then here we want to display R squared value on chart. Okay, so do you see we now have this equation. So the cost function is y is equal to 10.532 times the cost driver, the batch size, plus 24, which is the fixed cost. Okay, so R square also you can see 95.57%. That is very high level of confidence. So that all the dots are satisfied with this line. Okay, I want to just increase. Okay, this. Okay, and then let me figure this out in a statistical function as well. So 10.5 is the slope, and 24 is the fixed cost, and then R square is the just confidence level. So when you just use a statistical function, we use intercept Excel function, and then y-axis was only the numbers, and then here batch size as well. So it's xy, and then intercept is 24. Do you see the intercept, which is the fixed cost, and then slope is the same slope Excel function, and y first and x. So 10 is the slope. So the slope of this linear line under regression analysis is 10. It's very similar as this, very close to the cost driver under the high-low method, but it's much the accurate. The intercept, and then R square also R, then square also we want to drag y-axis and x-axis information. Okay, so 95%. Do you see we have a 95%? In the cost function, let's use that statistical information on the cost driver. What is the cost driver? Yes, the slope. The slope is the cost driver, and the fixed cost per month is 24.426 exactly. And then finally, cost function is y is equal to 10.53 cost driver from this slope x plus 24.426, which is the intercept or the fixed cost. So we got it. Okay, got it. And then expected batch size, the CEO expected one, predict is 25. It is given number from here, and then let's apply this 25 expected batch size on the cost function, 10.53. Oh, maybe we can get more exactly, not putting the hard number on the function, times 25, then plus fixed cost here, right? Then we got 287.72 is the predicted total cost for this 25 expected batch size. So when we compare this high-low and the regression analysis, it's very, very similar, but the regression analysis provide more accurate data. Why? This regression analysis considered all these dots from this historical data and explains 95% the confidence level. So this line now satisfy all these dots. But the high-low method is a simple, don't have to use this statistical the function, but we use just two numbers, two information. So it's not much accurate, but it's just a rule of thumb. So we use this high-low method as well. Okay, we have very similar result. Okay, this is it. See you next video clip. Bye bye.